Using the GGUF model with Sage Attention and Lightx2v LoRa reduced the video generation time from 12 minutes to just 189 seconds. In this video, I'll show you how to set up 1.2.2 in ComfyUI. So, let's get started. 1.2.2 video generation is fully upgraded. Cinematic Live aesthetic control, more stable and smooth dynamic generation, more realistic instruction following capability. We have prepared a cinematic video generation prompt guide to help everyone. Improve texture in aesthetic control, motion description, and stylize. In common aesthetic descriptions, we can try to fill in light source types such as daylight, artificial light, moonlight, practical light, firelight, fluorescent light, overcast light, mixed light, sunny light, etc. Light qualities can be described as soft light, hard light, top light, side light, backlight, bottom light, RIM light, silhouette, low contrast, high contrast. Time of day can be described as daytime, night, dusk, sunset, dawn, sunrise. Dot shot sizes can be described as close-up, extreme close-up, medium shot, medium close-up, medium long shot, wide angle. For composition types, we can describe center composition, balanced composition, biased composition, symmetrical composition, short side composition. For camera descriptions, focal lengths can be written as medium focal length, wide angle, long shot, ultra wide angle. Fisheye camera angles can be written as over the shoulder, high angle, low angle, tilted angle, aerial shot, top down angle. Camera shot types can try to include clean single person shot, two-person shot, single-person shot, tracking shot. Establishing shot color tones can be written as warm tone, cool tone, high saturation, low saturation, etc. In common motion descriptions, we can write some motion types, such as breakdancing, running, skateboarding, playing soccer, tennis, ping, PONG, skiing, basketball, rugby, bowl balancing, dance, cartwheel, etc. Character emotions can be described as angry, fearful, happy, sad, surprised. Basic camera movements can be described as camera push-in, camera pullback, camera move right, camera move left, camera tilt-up. Advanced camera movements. We can also emphasize handheld camera, complex movement, follow shot, orbiting shot in common stylization. We can try to describe visual styles like felt style, 3D cartoon, pixel style, puppet animation, 3D game, clay style, anime watercolor, black and white animation, oil painting style. If you want special effects shots, you can also add tilt-shift photography, time-lapse. Okay, now let's get all the files that we need for 1.2.2 and the workflows. First one that we need, obviously, is 1.2.2. Again, assume you have a 8GB VRAM laptop GPU. So the community has already created them within one day, which is pretty impressive. You'll find the full set here, and I'll share the link in the video description down below. On this Hugging Face page, you'll find a whole bunch of different quant values. Again, assume I have 8 gigs, so I've been using the Q4 just to make sure that I can run it and do the proper testing. I think I can probably get by with the Q5 as well. And obviously, if you have more VRAM, then you can go up to Q6 or Q8. If you have less, you can try out the Q2 or Q3. I think I've seen some people use the Q3, and the results have been pretty good still. So really, just grab the one that will fit your VRAM. The other big difference between known 2.2 and 2.1, at least for the image-to-video model, is that you need 2 of these GGUF. So you need the high noise one, and it's a 14 billion parameter one. For me, for example, I would grab the Q for high noise one. In addition, I would need the Q for low noise one. These get paired up, and I'll show you later in the workflow. These get paired up together to produce one video generation. Grab the quants that you need and put them in the unit folder, just like all the other gigaflops before. Next, we'll move on to the other important bit, which is the Lightx2v LoRa. This is the same LoRa that was used in Noni 2.1, and we can continue to use this in Noni 2.2, which will greatly affect the speed of the generation by default. 1.2.2 generations are 20 steps, so it takes a little bit longer. But with the Lightx2v, you can get it down to 6 steps for a really good generation. All the videos in the beginning intro were all done on 6 steps. From KJ's Hugging Face page, you want to grab the correct one, which is the I2V one. There's a whole bunch of different ranks here. The one I've been using in my testing is just rank 32. You can also go up to rank 64, or rank 1 to 8. So yeah, just get the one, either 32 and up, and then experiment however you like. The last set of files come from the ComfyUI page for 1.2.2. They've updated one of their guides here. Actually, there's nothing new for 1.2.2 unless you're using the 5B model. But because we're using the 1.4B model, you can just use the same text encoder that you've previously used for 1.2.1. You can grab it here if you don't have it. You also have to use the 1.2.1 VAE for the 1.4B model. So you can grab that here, or just reuse the one that you previously have. The 1.2.2 VAE is only being used for the 5B model, and it's actually quite a bit slower. So right now, you don't need to use that dot. Put these two files in the correct folders, and that's it. Okay, now we're back in ComfyUI. Here's just an overall view of the workflow itself. It's not super complicated, although it looks quite big, but I'll go through each of these nodes when I go through the whole workflow. So one of the first things you have to do before you start is to update your ComfyUI. Once you bring up Manager, you can update ComfyUI by clicking Update All or Update ComfyUI.Update All. I think we'll also update all the custom nodes you have. Just make sure you run this, then do a restart, and then refresh the browser window. When it's all done, you want to be on 0.3.46, and you can check this in a couple of ways. I didn't show you my ComfyUI version is because even if I have up-to-date, the workflow is not there. If you have the same issue here, just go to the ComfyUI official website, click Download JSON file, Control-A to select all the code, copy it, and then paste it in your ComfyUI. Now, I've used Theon to point 214B image to video as a base, and then expanded it with all the necessary extra nodes. Okay, let's go over the workflow itself. So first, we'll start on the very left with all the different loaders. The default one is the Load Diffusion model. I've bypassed those and then added the two from the GGUF custom node. So what you'll notice is there's actually two sets of models that are being loaded for this workflow. In one of them, you put the high noise, and then in the other, you put the low noise. So what happens is, in the video generation sampler, it'll actually split your steps into two, and then do half of it on the high noise, and then the second half on the low noise. So if you had 6 steps, for instance, you would set it up so that 3 steps would be done on the high noise, and the high noise is supposed to give you the dynamic motions, compositions, all that kind of stuff. And the last 3 steps will use the low noise, which will then fill in all the fine details. So this part is different from 1.2.1. from here. The two models go through the usual speed-ups that I add. And again, if you don't have Sage Attention, just look up how to install Sage Attention and the torch settings, and then you can add these two nodes. If you can't get it working, or if you don't have it installed, you can. Again, always just bypass all 4 of these, and then you can run the model. The model will still work, but it'll just be a little bit slower, okay? Next, continuing on the model chain, you have the LoRa loader model-only nodes. These two, you put in the Lightx2v, so the same LoRa, you add it to both. For the top, for the high noise path, you set it at 3. And then the low noise pass, you set it 1.5. These are the numbers that people have been experimenting with. These seem to give good results. For me, it gives pretty good results, so I've stuck with these ones. Of course, you can always just experiment and see if you get better results with other numbers. From the LoRa's, both of these go into the shift nodes, and these are default at 8. Each one of these models will actually go into a K-sampler of its own. So the top half with the high pass goes into the first K-sampler, and then the low pass one goes into the second K-sampler. These two K-samplers are connected by the latents. You also have a couple other things, plugging in here the positive and negative prompts into the same ones into both. And then the latent image from down below, which I'll explain now. If we take a look just underneath, we have the clip loaders, the text encoder, and the V loaders. These are just a general one from ComfyUI. You put your text encoder in here, make sure you have one selected, and then device's CPU if your CPU can run it. The VU, the 2.1 VAE, make sure that that one is selected. For the prompt connections, the text encoder gets hooked into the positive and negative prompt. In this case, because we're using Lightx2v, the negative prompt isn't actually being used, but it is being used in the default, which is why it's there. I also haven't had time to see if the one video neg has been updated and if it works for 1.2.2. Yet, though I've just left it at 1 without a negative prompt, but so far, the generations seem okay. The positive and the negative prompts actually get fed into the image to video. Then, from the image to video, it gets fed into the case. The other thing connecting the one image to video is obviously your load image. For an ITV model, you have to load your image here. The image goes through an image resize, which I've added just to make it a little bit easier to set your resolution on the output. You'll set it on the image resize. That gets passed to the one image to video. And then that resolution gets fed into the K-sampler. The one for B model for 1.2. 2 still uses 16 frames per second. So the length that you set here in this node has to be multiples of 16 plus 1. 81 frames is the usual 5 seconds for one, obviously. If your GPU is more powerful, or if you have more VRAM, you can also up the resolution on your image generation. You can definitely do widescreen 832 by 480, or if you want a portrait, it would be 480 by 832, or you can generate 720p images by putting 1280 by 708. I think that's on the 1.22, but you don't need to go higher than 720. I think the models are just trained on 480p or 720p as the maximum. Now we move into the K-sampler. Again, the first K-sampler is for the high noise pass, and the second one is for the low noise. What you see is that the high noise one has a seed, obviously, to denoise. This one looks more like the usual K-sampler settings that you would put. You have a seed. You can either set to randomize or fixed if you're trying to keep the same seed. Steps 6. Because you're using Lightx2v, if you want better quality, you can also do 8 or 10 steps. But just keep it a multiple of 2. CFG is 1. Sampler and scheduler. I've been using Euler and Simple. Some people have been using UniPC. I think you can experiment a little bit with these to see which ones you prefer. The last 3 are slightly different than 1.21. You have a start step at 0, end step at 3. This means out of the 6 steps, you only do the first 3 steps here. Then you pass the leftover noise as well. All of this gets fed into the second K-sampler. You'll notice you don't need a seed for this one, because it's taking input from the first one. You match the steps, so 6 CFG is the same. Same sampler, same scheduler. The bottom part, instead of starting at 0, you pick it up and start it at 3, and then end it at 10,000. Or you can put 6, but 10,000 you can just leave there, and then set the second one to disable. When it finishes a combined 6 steps, it'll go through the VD code and then into the video combine, which is quite normal. So here's a sample test video I ran, as you can clearly see. I'm using the Q4KS GGUF model with Sage Attention and Lightx2v LoRa, and it takes around 150 seconds to generate one video. I also tested the Q6K GGUF model, and guess what? No significant improvement in result quality, but the generation time jumped to 339.69 seconds. So yeah, feel free to use it if you're on a lower VRAM GPU.